In this problem, we have an absolute value inequality. So we're going to get two branches to work with, a positive branch and a negative branch because of the absolute value. Also, we have the absolute value already isolated, so we don't have to do anything before we write our two separate branches, which is nice. Notice also we have a less than sign, which means wherever we end up on the number line will be a small distance from the ends. The shading is going to be a small distance from the endpoints. So we're going to get a segment here because of the less than sign. And when we write the two branches, that means we can join them with the word and. So let's write our two branches. We have 3x plus 4 is less than 8. That is our positive branch. For the negative branch, you distribute -1 to the terms inside the absolute value, which will switch their signs. So 3x becomes -3x, plus 4 becomes -4, and will still be less than 8. And we solve each of these individually. First, on the positive branch, we subtract 4, and we divide by 3 to get 4/3. That's better known as 1 1/3. Maybe that's going to be easier to write it as a mixed number, so we know where to plot it on the number line. For the negative branch, we want to add 4 to both sides, which will turn our 8 into a 12. Then we have to divide by a -3, and of course, when we divide by a negative number, the direction of the inequality sign will switch, and then 12 divided by -3 is -4. We can join these two solutions with the word and we can plot it on the number line. We want to be less than 1 1/3. So 1 1/3 would be about there. I'm going to have an open endpoint because it's only less than, not less than equal to. -4 would, of course, be over here. We want to be less than the right side and greater than the left side. So we're going to get a segment in between. It would look something like that for your final solution.